said default.
Something default? Yeah, that sounds right. Watch that Helvetica movie? There's a there's a very intense movie called Helvetica. It is extremely intense. Yes, it is a documentary. There's a lot of people that get really upset. It's surprisingly intense. It's a dangerous.
Hello, everybody. We're about to get started. Our next speaker is Dean Pierce. He's going to be talking about they put money on the internet. So Dean Pierce is a security research from Portland, Oregon. He's locally affiliated with PDX 2600, RainSec, SoftSec, Control H, PDX Bitcoin, PDX BSides, Hackstuff, and Consensus Diligence. And here he is.
Hello. Is it pointed at my face? Okay, cool. My name is Dean. There's my Twitter. There's where we are, and there's what month it is. Okay. So I wanted to make this presentation such that it can be absorbed by a wide range of audiences. So I'm going to talk a little bit about some really basic blockchain-y kind of stuff in the beginning. Then talk a little bit about Web3 things, which is pretty cool. So some fun hackety hack stuff you can do. Then talk about a lot of the recent stuff going on the Ethereum network, especially like the decentralized finance movement-y stuff that's going on. And then, also want to talk about what a lot of weird people are doing with zero-knowledge proofs, which is kind of fancy. And then I wanted to shill a bunch of tools that my company builds. So here we go. So, okay, I'm going to gauging the audience here and helps you get some blood flow going. But who has heard of Bitcoin? Okay, we got what is Bitcoin? Okay, cool. Who has owned any Bitcoin? All right, we got a good crowd. Okay, and what is your private key? So, who has heard of Ethereum? Are you with the IRS? I gotta go. No. So, who has made transactions on the Ethereum network? Anyone? Transactions on the Ethereum network? Cool. Anyone developed Ethereum applications? All right. Typically Solidity and all sorts of fun. And has anyone hacked an Ethereum contract before? Anyone? Yeah, we got some. Good stuff. Cool. Blockchain. So, as a lot of people may have heard, the real interesting technology in the space isn't the Bitcoin stuff, but the blockchain. I don't know. I'm not gonna anyway. So Web3 is the next thing. Web3 is sort of an interesting concept of modern web development that it's using sort of this back-end blockchain-y ledger, but then also doing things like storing state, like the Bitcoin network, the Bitcoin ledger doesn't really have a concept of editable state, for example. It's pretty much like an append-only database sort of a thing, which is cool for a lot of things like financial transactions. But sort of this vision of Web3 stuff is actually adding business logic onto these widely distributed ledgers and then having a lot of monetary incentives like financial system, a lot of fun stuff. But anyway, I like to define it. So new model for building web applications where data and business logic are stored in a globally distributed ledger rather than on any particular server. And so the cool thing that this lets you do is essentially you can build a website that's somewhat complicated and interesting, and it can be served off of a static HTML page, say off of GitHub pages or whatever. And you can actually have some pretty complex back-end stuff, but you store all the data on the Ethereum network, which is kind of neat because then it goes out to all the nodes and people can interact with it. And anyway, good stuff. Ethereum, magical sky computer. Ethereum has a bunch of different networks. There's a mainnet is the main network I guess. The mainnet Ethereum is what you would say like has value typically. They have a lot of these other networks, the Kovan network, the Rinkeby network, the Ropsten network, and if you do any Ethereum development, you can acquire these other Ethereum tokens with like various degrees of difficulty. Like Rinkeby, like you have to sort of prove that you're developing something in the space. Ropsten is kind of like a free-for-all. It's like a super easy to get Ropsten ETH, and then you can do some crazy stuff with it. And the general idea behind Ethereum is you send a transaction, and instead of sending money from point A to point B, you're pushing a contract to the network, right? And a contract is essentially just it's like a script, and you can do things like it's super duper easy because these are Turing complete scripts essentially. So for the computer sciencey people, like you can do whatever you want. It's super duper easy for you to create a program where two people pay $5 so that they can play against each other a game of tic-tac-toe, and then the winner gets $10. That's like a trivial thing that you can implement. And so that's a good example of, you know, money goes in, money comes out in like a funny way based on business logic backend. The contracts are essentially like, for people familiar with object-oriented programming, they're objects on the network. Any contract you deploy is essentially an instantiated object. And you can interact with it by calling methods, and when you call a method, you're sending a transaction that says, hey, you know, particular this method, use these arguments, do something. Sometimes you can attach money to those transactions. You don't necessarily need to. And the idea is that like once you push these up onto the network, they're just there kind of forever. There are ways to delete your contract if you add that functionality in, but by default, you don't need to. And actually, the ability to delete contracts has had some like massive financial losses. There's been a lot of pretty bad screw-ups where people have accidentally let people delete certain parts of contracts, and now there's like many millions of dollars locked up because of they weren't too careful on the permissions of who's actually allowed to delete the contract. So most people now just like don't let you delete contracts. So they're up forever. It's pretty neat. And anytime you want to read data out of the state of any of these contracts, it's like totally free, which is nice. When you write to it, it's probably going to cost you like 2 cents. And then you're essentially now you're using this blockchain as the back end for all your fun stuff. And one of the cool things I like to tell people is like, you know, you can run these crazy Ponzi schemes or do whatever you want. You can deploy these contracts. And like, even if you go to jail, like the contract is still going to be there. They're still going to be running. There's nothing that anybody can do to stop them, which is very different from like the current system of like, you know, running a centralized server in a data center somewhere or whatever. So that's kind of a really neat, fun thing of that. So this is what it looks like. It's kind of JavaScripty. So this is a contract that I wrote. It's called Stupid Contract. It has a list of stupid stuff. And you can add, there's this method here where you add a string, which is something stupid, and then it pushes it to the array. And then you can get the count of how much stupid stuff there is. And so pretty simple contract. This is just a very basic demo of storing state on the network. Yeah, here we go. There's this great tool called Remix. I'm gonna check it. Remix is an IDE, an integrated development environment, and you can actually, it's very, very nice. It's very pretty. It's well like instrumented. Everything's great. It's got good debugging options and everything. You can go there at remix.ethereum.org, and it's all completely like it uses your local storage to store your code and everything. And so it's like it's really cool. It is kind of like in the browser. So this is just a demo of kind of what that looks like. Remix has done a massive overhaul in the past few months, so it doesn't really look like this anymore. Like all of these cool buttons for interacting with the contract are actually over here now. But in general, you get the idea. Your code is here, your output is here, and then when you deploy a contract, it's actually like here's the contract, here's the address that it's at on the blockchain. Here's these functions, like, you know, people who get mad at Facebook, like there's all sorts of like stupid stuff, and then you can like hit the thing and it all works. Yeah, it's good. When you deploy a contract, this is what it looks like. This is called a block explorer. It's very, people who are familiar with other blockchain stuff should be familiar with the concept of block explorers, where you're, in Bitcoin, it's pretty much used to look, has the transaction arrived to me yet? Like, where is it? Has this transaction happened? And you can look at, where money is coming from, where money is going to. And because it's this globally distributed ledger, everybody on the network can see all the transactions that are happening. And so Etherscan is a very nice IDE, or not, it's a very nice block explorer for the Ethereum network. And this is me showing what happens when you deploy a contract. And see the input data, is that, okay, it's popping up a thing over there. Anyways, the input data is like this giant blob of thing, and you see it starts with a OX60604, and this is the little header that says like it's time to build a contract, and then the rest of it is just executable code in like the Ethereum virtual machine. So it's like virtual machine code that is now published on this globally decentralized ledger, and then anybody can call functions on it and do stuff. So does anybody recognize this Fox? Yeah. Okay, this is the MetaMask Fox. MetaMask is cool. Here we go. Yeah, MetaMask. MetaMask.io. Also, it's a consensus project, so the company I work for is like working on this. The company I work for does a bunch of weird Ethereum stuff. Anyway, MetaMask essentially is a browser extension, and what it lets you do is the MetaMask plugin talks to the Ethereum backend, or not, like it talks to the Ethereum network, and then it lets you use JavaScript from within your website to essentially read and write data and to do stuff. And so you have your website here, it's all pretty, you click buttons, and then it's translating that into the backend, and it does the key management and stuff too. So your MetaMask is also essentially like an Ethereum wallet, where you hold a certain amount of, like, you can hold like $5 of Ethereum, and then anytime you want to write something to the network, it's going to cost like 2 cents or something. But that's kind of how all that works with the web stuff. I got an example. We're not going to do this here, but if you wanted to, or like see this or screenshot, like you can go play with MetaMask, and it's fun. Anyway, so yeah, I don't like paying for servers. I'm kind of a cheapskate, I guess, on the internet, and anytime like GitHub will host my code for free. NeoCities is great if Kyle is here. If not, then I don't know. And like servers are dumb, and so you can have a backend that's essentially free, and then you make your users pay for interactions and stuff. It's great. It's this whole new thing. Anyway. I also have a thing, so Namecheap started accepting Bitcoin a while back, and so I went kind of crazy buying a bunch of domain names. Anyway, I have this domain name, which is actually going to expire in a couple days, and I don't know if I want to renew it, but it's stupid.site. It's a pretty cool site. Anyway, essentially, so it's actually, if you visit stupid.site right now with a Web3 browser, which includes like Chrome with a MetaMask plugin, and there's a bunch of other Web3 browsers and stuff. But this is actually, it's live right now, and this is a list of stupid things. And then you can just click that add stupid button on the bottom and like add a new stupid thing to the list. And then it's like on the blockchain forever, because there's no functions to delete stupid things. So anyway, that's exciting. So stupid.site. So what else are people doing, right? Who here knows CryptoKitties? CryptoKitties? Yeah. Anybody have any CryptoKitties? I have 4 beautiful CryptoKitties. We got a lot of CryptoKitties owners. This is, whoa. Yep. No, CryptoKitties is neat. So there's in the Ethereum space, the protocols, the standards are typically referred to by like their ERC, or it's the like Ethereum request for comments, or like Ethereum improvement protocol or proposals. So there's ERC20s, which are like, the basic tokens. So like there's a whole bunch of different types of tokens out there, like basic attention token and like a bunch of other stuff. And there's also, as of a few years ago, there's the ERC721 tokens, and those are the non-fungible tokens, which the CryptoKitties pretty much maybe invented, and they were the ones that really first started making it, and it kind of took off. But it's essentially the ability to own like a little object. It's just a little token with a serial number attached to it and some metadata, and then it represents an item that you have on this blockchain. So you get these kitties, and then you can give them to other people. You can also breed the kitties together, and they'll make more kitties, and kitties have value, which is crazy. I just took this screenshot a few minutes ago. Here's this kitty being sold for $191,000. Here's one, $181,000, $27,000. These are expensive kitties. Okay. So this is a real live thing that people are doing, right? Okay. Yeah, this is a thing. And the great thing about CryptoKitties is it's just a website. Like, you install MetaMask, and you go to the website and you're interacting with the Ethereum blockchain, but it's entirely through the JavaScript and like the beautiful UI stuff that these people have made, which is pretty cool. So like even if their company like gets sued into oblivion for some, cat-related reason or something, it doesn't really matter. Like, you still have your CryptoKitties forever, and so that's kind of neat. Yeah. There's a bunch of other weird stuff going on the network. There's this Moloch DAO thing, which is so a DAO is a distributed anonymous organization, and so it's essentially DAOs are groups that people can join this group on the network, and then they can use voting mechanisms to affect events. And so like what Moloch DAO is a bunch of people put in a bunch of money, and people are essentially voting for what parts of the network need to be funded. So they'll fund a security audit or the development of a new block explorer or like a lot of other new things. And so it's really meant as this way to have this kind of, it's not really a governing body because it's like a totally decentralized, like, any weirdo in the world can join this group and they can just vote on where money goes to. So it's kind of interesting that they have like this political influence. And there's actually a whole bunch of different groups that are now doing very similar things. Like there's a Panvala is also doing a lot of group funding stuff. The Ethereum Foundation itself was the original group that decides, who gets what money, which is why a lot of these other ones sprung up, because I think, why is the Ethereum Foundation funding this but not funding this? And so you get all these, like, I don't even want to say competing, because it's all like, working in the same ecosystem. Different people can choose different mechanisms for funding different things. So it's a fun system. There's this thing called Uniswap, which is super cool, which is essentially, it lets you convert any of your Ethereum tokens into any other Ethereum token. And yeah, it's a pretty powerful thing because there is no centralized server. There's no, this one guy, Hayden, wrote this and deployed it, and it just exists now. And anybody can move money from point A to point B, and they can essentially, it is a decentralized exchange. So it's very difficult from a regulatory perspective, because there's not a central company that's actually holding everything, which is kind of crazy that it's all just I don't know, money goes in and out, and it's all crazy. It's not a mixer. It's actually you're just purchasing coins. It's all visible on the blockchain. People can see, coins go in, coins go out, and whatever. But it lets you, if you have Ethereum and want to buy some, I don't know, say some basic attention token or some storage tokens or some whatever. There's all these different ERC20 tokens that incentivize different things on the network. And yeah, so it just lets you convert one thing to another. And actually, if you look on CoinMarketCap, which is a big list of the top cryptocurrencies, a massive portion of them are Ethereum tokens. And so they're on the Ethereum network, which is largely because you have these kinds of systems that have this network effect where, people can trade tokens, and people don't want to run their own kind of blockchain or whatever thing. And so you can use an already well-established network and just deploy new tokens on. And I've done it, and any weirdo on the internet can just deploy a bunch of new tokens, and you can make tokens that behave in funny ways and whatever. But you can make tokens where you can blow up prime number people's tokens or something, whatever. you do a lot of cool stuff here. But yeah, so Uniswap is an interesting thing, and there is insane amounts of money moving through Uniswap, which is also weird. There, yeah, MakerDAO is another big one. This is the mechanism behind the DAI token, DAI, and the DAI is a USD, like US dollar pegged ERC20 token. So it is a ERC20 token that is always worth $1. And the way that works is because of the way these collateralized loan mechanisms work. And it's kind of interesting. It's like a decentralized exchange, or yeah, it's a decentralized mechanism that allows the pegging to a like US dollar asset, which are like any real world asset. I don't know, it's weird. And then a layer above that is this thing called Compound that you throw money into and then the money goes up, which is cool, right? And so if you look at the DAI, this is all just using MetaMask too. You don't have to create an account with a username and password or anything like that. It's just straight up like you install your MetaMask thing, you load say $10 into it, you go to what is it? Just the compound.finance website, and you can click a button, and then you deposit DAI into their system, and then you're getting this like 7.4% APR, which is being generated from, I don't know, a lot of complex fun math or whatever. But no, it's super legit. Everybody should put all their money in it immediately. No, but no, it's an interesting system. Anyway. So hacking. Okay, we're all security people here, right? So one of the biggest hacks from like way back in 2017 was like the DAO hack, and a lot of people heard that, and there's many millions of dollars that were stolen. And it was from this reentrancy bug. And really the counterintuitive thing here is that if you deploy a contract and the contract gets an address, and the address looks just like a normal Ethereum address, and so when you send Ethereum to somebody, and that somebody is a contract, what you're also doing when you send Ethereum is you're executing a callback function, essentially. Or it's the fallback function on a contract. And the fallback function can really do whatever you want it to do. And so if you can trick another contract into sending you money, if you can send to like an arbitrary address, like, this is my reward address, if you can send it, you're essentially able to execute arbitrary code and then do some other fun, weird stuff. So, yeah. So this was a challenge that I did way back in time, or back in the day. And this is a wallet called the HODL wallet. And this was there was like a Polyswarm, whatever, token hacking competition from, it was like a little more than like a year and a half ago or something. And yeah, and what this did is they would create an account for people, and that account had 0.1 Ethereum in it, which was at the time something like $80 or something. And it let people withdraw money from the contract, but they could only withdraw it 3 times, and they could only withdraw 0.002 or less. And so really to get everything, they would need to withdraw 50 times, but because they have certain logic in their contract that says you can only withdraw 3 times. So there's this do withdraw function, enhance. Okay, cool. So this is what it looks like in the withdraw function. It makes sure that that the amount that you're trying to withdraw is less than that 0.002 or whatever. It's requiring that you actually have that much Ethereum in your account. You're not doing like more than whatever the 0.1 Ethereum designated to you. And then it's making sure that you have withdrawn less than 3 times, right? And so the first thing it does is it subtracts your balance from the total balance in the wallet. And then it sends the money to the to address. So the to address is getting passed in of where the money is sent to. And this is an old way of doing I don't know. It's a way of doing of sending transaction value, because then this is the to address, and you say call, and then you set the value to the amount that you're trying to send. So you're sending Ethereum to that address, and then you're saying, okay, now you have withdrawn once or twice or 3 times, and so you can never withdraw more than 3 times. So here, the reentrancy is because this increase in the withdrawal count happens after this function happens. And so it turns out you can re-enter on this to thing, and then you call the do withdraw from this like over and over again until you loot all the money. So I'm gonna dig a little bit deeper into that. There's a concept of malicious smart contracts. I made this ninja.sol. This is the contract I use to loot the HODL wallet. Here's a zoom in on the fallback function. And so anytime that anybody sends money to this contract, what it does is, this is the address of the HODL wallet, HODL equals whatever, and from is my personal address that they created for me for the challenge. And so I'm withdrawing from this person's wallet, and then this is the address of the HODL wallet. So I'm doing hodl.call, and then I'm using this withdraw for function, and then I'm withdrawing this 0.002 Ethereum. And this happens every time that I get paid, and so what I'm doing is I do the withdraw, it pays this contract, and then it goes and then it calls the contract again, which then falls back to this function again, and then calls that contract again, so it withdraws 0.002 over and over and over and over and over again without ever increasing the total withdrawal account, which is pretty fancy. And it looks like this. So I thought, like, when I actually looked at the block explorer and saw what was happening, I thought this was the coolest thing ever, because this is, you're only supposed to do this 3 times, but then it's all stacked up, and you can see it's like, it's in the same transaction hash also, this like BC855 or whatever. So in a single transaction, I'm doing a whole crap ton of withdrawals, and this is me taking my 0.1 ether and going home happy. So, yep. Wow, what's all this? Okay, yeah, weird stuff. Okay, yeah, there's some weird stuff I wanted to talk about that like didn't fit in a lot of other places. There's a lot of, it's a weird world in here. But yeah, reentrancy, we talked about that a little bit. It's kind of, it's not super common, like that exact kind of anti-pattern in like across the software space. A really interesting attack is this front-running attack, which actually comes from Wall Street, essentially, where, you know, back in the day, like you would overhear that somebody's, you know, gonna buy this thing. 2 what? 2 minutes? It's not an hour? Oh, yeah, okay, cool. Yeah, so front running, it's like we're literally, that you like run ahead, and then like, you overhear that somebody's gonna buy something, so you go up and you buy a bunch of it first, and then like it, like, you can buy it before the other person gets it, so you can get it at a higher value, or get it at a lower value, and the price goes up. But in the Ethereum space, all of the all the transactions happen kind of public in the open or whatever, so everybody can see what's going on, and so it's really easy to see somebody else is moving something, and so you can like shove something else in front of it and do whatever. So, yep, good stuff. Ownership, a lot of people have overpowered ownership stuff, type confusion, shoving weird contracts into weird places. Yeah, so there's an interesting thing, because you're in a smart contract, you can do this thing with determinism, where you can say, you know, do this thing, try to win this lottery, and if the random number doesn't turn out in my favor, then revert. And revert essentially means like this transaction never happened. And so that's, yeah, pretty good. And the cool thing about that too is offensively, if you're trying to steal money from something or do whatever, you can also make it so that it never happens unless like you can see how much money you have in the beginning of the transaction, and see how much money you have at the end of the transaction, and if you don't have more money at the end, you can revert, so then it's like nothing ever happened. And so you have zero risk. You can like attempt multiple times and do all sorts of crazy stuff. And I wanted to talk a bit about, so the way that reentrancy actually happens usually these days in modern contracts is you have, it's usually people want to let users say like do whatever with like a certain token, but the thing is that token doesn't necessarily need to be a real token. You can have a contract that has like a malicious transfer from function, and so you put in the token address in the thing, and then the contract calls transfer from, but it ends up actually it's calling some other malicious thing, and it's exciting. So, yeah. You're right. Okay. Cool. Okay. I got lots of time to yell at stuff. Good. Whew. Okay. Anything I want to go over better here? No, this is all good. Yeah, you can win all the lotteries. Anyway, there's a concept in the Ethereum network called oracles. So everything, like all the smart contracts are like totally deterministic, right? So there's no like, there's not really a good way to bring information from the outside world into the network. And so if you are a smart contract and you want to know, say, the price of like $1 to Ether or whatever, that's not, you can't just write a smart contract that like does like a JSON request and does a thing. Like that's kind of, it would sort of break a lot of the determinism because like who knows, like the backends could be different every time or whatever. So you can't really touch the outside world. You can only kind of do things on the inside. And so this concept of oracles exists. So a lot of people have deployed smart contracts that have, the price of Ethereum to $1, and they exist on chain, and anybody can read from the contracts. But then it's kind of like, how much can you trust that this contract is legit? Because the real world changes frequently, and the Ethereum network only changes every 15 seconds, and it's like, and there's not really a lot of good solutions out there because if you have like a very centralized oracle, a centralized oracle means that there's a company that runs it. And if this company gets hacked, their keys get stolen, then anybody can put whatever number they want in there. And then if they do that, then they can cause like some crazy market swing or like automatically trigger a bunch of other crazy stuff. And that's kind of bad. A lot of places so that they don't have to be responsible for that, they have very much democratized their oracles, and so you essentially have this system where like hundreds or thousands of users are essentially voting to see like what the number should be, right? Which is also kind of crazy, because then if you like buy up enough influence that you can like shift what the number is supposed to be, then you can like maybe you spend $100,000 to manipulate the oracle, and then that lets you net like $10 million or something. And so you have this malleability versus centralization, which is kind of this back and forth, and it's always like somewhere in between there, usually, for any given oracle on the network. Okay, I want to talk about decentralized finance. And so I'm going to take another drink of water. So we talked about decentralized exchanges earlier. That's essentially, you can have decentralized order books where, I have this asset I want to sell, I want this price, and then like people can buy it for that price or whatever. Like people put in order books, and you have like the makers and takers, and it can all be kind of on the network without having to have a central, like a pool for a lot of this, which is kind of cool because then you see a lot of transparency. Like you can actually see what's going on, and it's not like, that you're not necessarily being cheated by whatever other system because things are decentralized, which is cool. Automated market makers are certain things like Uniswap is an automated market maker, and that's like instead of having an order book, it's like an exchange where it uses some algorithm to automatically determine the price of a given asset. So you put one asset in one direction and it pops out the other direction. Lending markets are another big thing, and like where people, you put out like a certain amount of an asset, and then like there can be like an interest rate, and then whatever, and you take it out and do all that. And people are making like derivatives and synthetic assets, and it's pretty crazy how this world's going. So here's some charts. Up here, this is MakerDAO. So this is these are some really nice charts from a group called Alethio, which is also part of Consensus. They do very pretty charts, and they have a really good like block explorer and financial stuff. But anyway, this is November 2018. This is less than a year ago. And this is what the DeFi space kind of looked like. You had a bunch of people doing MakerDAO stuff. There's like some Augur prediction markets. Here's Compound, which is that, you know, put money in, money go up kind of thing. Like, it's a pretty neat. Anyway, so how it's kind of evolved over time. So this is November 2018. This is May 2019. And yeah, we're starting to get into Uniswap. Uniswap was deployed around December 2018. So Uniswap started getting up a lot of popularity, and it very quickly grew because it's such like an automated system, and it was very easy to write a contract that automatically would convert tokens into other tokens or whatever too. And so all these contracts are kind of like pointing towards each other and like will use each other to do things. Okay, here's August. And you can see it's kind of exploded into crazy town. And yeah, and this is September. So yeah, you can see it's there's a large number of people and a large number of projects, and the amount of money moving through these contracts is kind of insane. And there's a really great chart that I couldn't find when I looked for it, but it was showing how the stack depth of your average transaction over the past year has skyrocketed. So typically, you know, with the typical contract interaction, like you buy something, or like you move something, or you get a crypto kitty or whatever, it's maybe one contract which calls another contract, and maybe that calls another contract. But with some of these systems, like the 0x relayers and like all that, you have entire ecosystems that are relying on other ecosystems, which are relying on other ecosystems. So you can do a single call that actually ends up going like 4 or 5 deep, and it's just kind of like average stack depth has been like hockey sticking in the past few months, which is super interesting. Yeah, here's the amount of money that is sitting in these contracts right now. The Maker contracts have $303 million. Compound currently has $151 million. And you can like read the rest, but it's not a trivial amount of money sitting in these smart contracts right now. So remember oracles? So a lot of, for example, the Maker stuff depends on collateralized, like over-collateralized lending, which seems kind of counterintuitive, but essentially you lock up $300 to borrow $100 kind of a thing. And the idea there is essentially the same kind of thing where you take out a second mortgage, like you put up your house as collateral so you can go to the casino and win a bunch of money, and then you pay your house off, and then like, you know, it's good times had by all, right? It's the same kind of general concept, but it is very commonly used in the Maker system for, you know, the situation where I want to buy more Ethereum, but all I have is Ethereum. So you lock up a bunch of Ethereum, and then you get out some DAI, like the US dollar tokens, and then you use that DAI to buy more Ethereum, which you can then use to buy more DAI, which you can then use to buy more Ethereum. So you're essentially, you know, going along on Ethereum and having a highly leveraged position in sort of this decentralized way, which is kind of cool. And the thing about these debt positions is if there is a sudden price shift and, you know, the $300 to $100 goes below, like if the price crashes and suddenly, you know, the amount that you have locked up is maybe $80 when you have like 100 DAI or whatever, suddenly what that means is like you don't want to repay that. But the way that that's dealt with is you have the ability to get liquidated, essentially. Is anybody, like, as you start nearing your collateralization threshold, people can essentially take the pile of money that you have locked up. And so the interesting thing about that is that they depend heavily on oracles, like price oracles specifically. And price oracles, as we've discussed earlier, are very hard and they can be malleable. So there's this great researcher, Sam, who has been like breaking the crap out of everything in the Ethereum network for the past maybe a year or so, like a lot of really great work. But he posted a blog on like the 30th of December, and he showed a whole bunch of these different systems, collateralized loan systems, where you can manipulate the price oracle and then essentially loot and get free money from it. And like one of the examples that he had was essentially in a single transaction being able to grab like, I think it was like 73 Ethereum, which is pretty good. What's it, like $150 or something right now per Ethereum multiplied by, yeah, it's a good amount of money. And that money is just kind of like sitting on the network, because all you need to do is like, you can buy up, you can manipulate this one like oracle over here, which moves the liquidation threshold, which lets you trigger the liquidation event, which lets you run away with all the money and then be like, ha ha. But anyway, so it's a very interesting kind of world that we're going into with all of these like over collateralized positions and everything. Yeah, and you pretty much have to do, like if you're doing any lending at the moment, the only alternative to over collateralized lending is like lending based on trust. And we don't really have good trust networks established on Ethereum. It would be very easy for anybody to create a new account, take out a loan, and run off with all the money, right? And so right now, pretty much all the lending that is happening is all this over-collateralized lending, which is interestingly vulnerable to whole new classes of weird oracle manipulation attacks, which is kind of cool, I think. To sort of completely change topics a bit, now that we're all excited about decentralized finance, I wanted to talk about mixers. So this is a mixer. Tornado.cash, it exists today. You can install MetaMask and put in a bunch of Ethereum and then take out Ethereum. And the way that Tornado.cash works is it's using ZK snarks for people that are familiar with a lot of the new zero-knowledge magic going on these days. And it's essentially fancy zero-knowledge proofs that cloak certain information about certain transactions. And what you do in Tornado.cash is you put in 0.1 Ethereum, and you can do this as many times as you want, but you put in 0.1 Ethereum and you get out essentially a ticket, right? And this little redeemable coupon or something. And then you can kind of take that, do whatever you want with it, like, I don't know, put it in a lockbox for a while, and then maybe a few months later, maybe a few years later, you can take that ticket and you redeem it, and you redeem the ticket, and then it withdraws that 0.1 Ethereum from the contract. And there is no way mathematically to associate the deposit to the withdrawal, which is kind of neat. Obviously, if you're depositing it and withdrawing to the same address, that's not good. There's a lot of OPSEC fails you can do here. But in general, like, the math is pretty neat, and there's a lot of ways that you can, that it can introduce a lot of very strong privacy on the network. And this is all very new. This is the past couple months or so. A lot of these mixers have come by. I think there's like 4 or 5 now. Most of them are just on testnet, which is probably good for testing. Tornado.cash does it live on mainnet, which is awesome. And they got hacked. But it was neat though. It was responsibly disclosed, and they figured it all out. And there's this really great blog post actually that goes into the technical details. But it was a bug in the CIRCOM libraries, and CIRCOM is essentially a set of zero-knowledge circuits that are used to do fancy zero-knowledge stuff. And it is very complicated, scary math. But from, like, once you have these, like, CIRCOM circuits, it becomes very easy to do basic mathematics, like A plus B equals whatever. Like, you can stack together this circuit, which then, just like you would with a typical like electronic circuit, and then you compile it like using this whatever fancy code, and then it outputs magic zero knowledge proof sauce that like makes everything invisible and crazy. And so there was a bug here where they used equals instead of this like, I think it's like a left wire operator or something like. So because they used the wrong operator, it essentially allowed you to forge the receipts that would let you take money out. And there have actually been 2 bugs that are very similar to this in the past like few months. And this is first of all, this is very new mathematics. Like the papers that this math comes from are like all published in the past couple of years, which is crazy. And, it's very new, I mean, from like just computer science-y from like a software side too. So there's a lot of really interesting potential security issues here, and there's like no tools to detect anything like this, which is super interesting. And so that'll be interesting to keep an eye on over the next, year or 2, because I'm thinking like, as people start developing these tools, maybe in private, maybe in public or whatever, you can imagine people are building these mixers and they start building it into the DeFi network, right? Where you have a bunch of other crazy stuff going on, and then being able to do some crazy like jujitsu and like taking money out using math that has only existed for a couple years is an interesting direction that we're going as a global world. Let's see where we at. Oh, cool. Yep. So shameless plug time. Okay. So I work at a company called Consensus. Inside of a group that's like Diligence and MythX. We do like all the security stuff in there, and there's maybe, I want to say like 30-ish of us. I don't know. But yeah, one of the early tools that came out of our group was written by Bernard, and he wrote Mithril. Mithril is a symbolic execution engine. You essentially point it at a blob of EVM code or source code, and it uses really fun like SMT magic to like solve some cool stuff. And one of the things that we've built on Mithril is Carl. Carl is really neat because you point it at a blockchain, and this is written by my coworker Daniel. And Daniel and Bernard gave a really awesome talk at DEF CON. I don't know if the video is up yet, but like the moment it goes up, you should totally watch it, because Daniel wrote this thing where it essentially watches any given blockchain, waits for contracts to be deployed that have money in them, and then it can go off on like a test net and then try to steal money by the test net. And then if that works, it can then just steal the money directly from the mainnet also, which is a pretty cool tool, right? And so you can just run this all day long and just like wait for vulnerable contracts, and it keeps a log of the vulnerabilities that it finds. Like if it's if it's just like an int overflow or whatever, it'll record that. But there's a detector in there for, anybody can take all the money, which is kind of a neat thing to detect in a thing that is just on the internet. So another tool that they demoed at their talk at DEF CON was Theo. Theo is kind of a more interactive, like the Metasploit of Ethereum exploitation. And what Theo allows you to do is, it gives you a lot of additional options for like interactively exploiting with stuff. And you can, things that have been found from Carl, you can then import into Theo and then like exploit them. They gave a really great demo this summer where they had set up this exploitable honeypot, which is a Ethereum contract that looks like you can steal money from it. And the funny thing about those is that there's a ton of them that go up online, and they make it so maybe you have to put in like 1 Ethereum to exploit it. But you can do all the tests and it looks like you can totally exploit it and it's totally legit. And they did it, and they put some money into it, and they were waiting for somebody to exploit it, and then somebody attempted to exploit it. But the neat thing about this honeypot that they put up is that the contract, or the function for exploiting it was also front runnable. So he had this Theo set up to do front running. And so it waited for the transaction to come in on the network, and then it shoved like the moment it saw the exploit transaction hitting the network, it put in another transaction on the network. And if you pay more gas for your transaction, it will get ordered first. And so it happens before the victim. And so, yeah, and so it was, you front run it to change the owner, and then the second transaction goes in anyway because that puts in the deposit, and so that put in the money, and then he could withdraw to take the money out. And it was funny and it worked, and he ended up giving the money back, and we don't know who that was that did that, but it was a hilarious thing. And they show all the hijinks on the DEF CON thing, and like my time is almost up here, so. But definitely go watch that DEF CON video when you have the chance. Legions is a new tool. My coworker Cheyenne wrote it. It is for essentially scanning the Ethereum network itself. It will connect to the different nodes on the network, and you can check their configuration status, like version numbers, like do all sorts of really crazy stuff. And like a lot of people will configure their node maybe incorrectly that lets you do things that maybe shouldn't be allowed to do. And so, yeah, he wrote a bunch of really fun stuff there. Coworker Martin, 1010 Web, he wrote this VS Code plugin. It's very beautiful. It does a bunch of syntax highlighting, but then it also does like call graph, flow graph analysis stuff, and it's very pretty. And like you click it and it's animated. And everybody should install that. Like if you're doing anything with Ethereum, you should just install his VS Code plugin, and it pulls in a bunch of other VS Code plugins that are also cool, and then it lets you do fun stuff with it. Also, more of the stuff that I'm working on is like this security as a service MythX platform, where you can throw source code, throw bytecode at it, and then it spits back a bunch of vulnerabilities, and it's got this nice pretty web dashboard that tells you all the vulnerabilities of stuff. And I've been recently writing a bunch of tools for doing throwing it into continuous integration. So like when you like anytime that anything changes on GitHub, it can like automatically scan and then like re-upload everything to MythX, and then you get all the newest security issues and everything. So I don't know, it's a pretty fun project too, and it's freemium too, so it's free for anyone to use. It actually integrates really well with Remix. Like if you want to use that web IDE that I said earlier, there's like a little button where you say like, you know, add the MythX plugin, and then you can just like hit a button and it uploads all your code to MythX and then scans it. If you don't pay us money, we will only scan it for something, I think it's like 30 seconds or something. But that will find a lot of issues, especially in small contracts. But for larger contracts, like, because we do all sorts of like fuzzing, and like symbolic execution can sometimes take a long time if there's a lot of branches. But if you pay more money, you essentially, like it'll scan for like, say like a half hour instead of just like a handful of seconds. Then you'll go a lot deeper and find more bugs, and it's good stuff. So we get you hooked with the early easy bugs, and then, yeah. Anyway, good stuff. Everybody should go play with that. Here's this like tools website that has the tools that I just talked about, and everybody should go there and download and play with the tools. Follow me on Twitter, hit the bell, capture the ether. Play these CTFs. These are fun CTFs. Also, can I take questions? Are there questions?